Chapter 4.1, which is properties of linear functions and models. When a linear function represents a real world problem, it is called a linear model. And we know that that form is fx equal to mx plus b, where m, the slope, represents some rate of change. Could be something like, say, dollars that you make per hour, or how many miles you're driving per hour, how many stairs you climb each second. Anything that might be considered to be a rate of change would be considered to be slope. How many tacos you eat per minute, all of those are rates of change or slope. So it's used to represent variable costs. Sorry, the equation f of x represents variable cost, and you can also pick out things like how much you get paid or how much your cell phone bill is. Etc. Okay, so we're going to look at 4 examples of problems that actually use linear models. Okay, all right, here we go. Suppose that the quantity supplied S and the quantity demanded D of t-shirts at a concert are given by the following functions. S is equal to negative 250 plus 60. You notice that has a positive slope. And the demand function, 1100 minus 75p, is notice that has a negative slope. So the very first thing you want to do is to graph these functions. I'm going to pause this for a second. Okay, so I'm going to go ahead and open my calculator and put these two functions in as y1 and y2. minus 250 plus 60p, and 1100 minus 75p. Okay, so notice I put them in my calculator into y1 and y2. Now, if we try to graph this function, we are not going to see anything much because we just see some kind of a line there. And that is because the numbers are so large. The numbers are so large that we have to fix the window. So at this point, you would go to the window. Notice that the y-intercept in the first function is negative 250, and the y-intercept in the second function is 1100. Okay, and then x goes 60 and 75. So let's see how we can mess around with the window first. First, we go down to the y-intercept. We want to fix it for negative 250. Okay, that negative 250. So let's say we went about negative 300. And then on the positive is 1100. So we're going to take the y maximum to say about 1200. So we're getting somewhere with the graph. We're not there yet, okay? All right, now we want to see we can see the part of the graph here. So let's go ahead and we're going to put x minimum as 0. We don't need to see the minimum because we're talking about money. And let's give x maximum, let's try about, say, 40 or 50. Let's try, I don't know, 30? Let's try 30 and see how the graph looks. Perfect. So this is the graph of our supply and demand. Let's go ahead and copy this. I'm going to go ahead and copy this and paste it into our graph. It's showing one of the graphs here. So actions, capture the screen, copy it, and we're going to put it on the side of the notes right here. Okay. Notice the graph with the negative slope is the demand equation, and the graph with the positive slope is the supply equation. So this red graph that doesn't show is the equation for y is, the demand is equal to 1100 minus 75p. Now they're asking us to find equilibrium price. The equilibrium price is the point at which demand equals to supply. Okay, remember here that P is the price, so the X value here is the price. So they're asking us to find that point right there. That's the equilibrium point. Okay, they're asking us to find that point. To do that algebraically, we would set the two equations equal to each other. Set the first equation equal to the second equation. And solve it. Okay, solve it just like you would solve any normal equation to find a value for the price. So I'm going to rearrange this as 7 and 6, 13, so 135p. I'm expecting that you guys can solve this very easily. Equal to 1350. Okay, add 75p to both sides and add 250 to both sides. So p is equal to 1350 divided by 135, which is equal to $10. Okay, so that equilibrium price is $10. $10. Okay. Now, if we wanted to find the equilibrium quantity, which is the Y value, or, remember at that point, both supply and demand would have the same equilibrium quantity. Okay, so if we wanted to find that quantity, we would write take any one of the equations and substitute for the price. So substituting, because the equations are equal, we can pick any one of the equations and get the answer. So substitute it in the first equation is equal to negative 250 plus 60 times 10, which is equal to 600 minus 250, or 350. Now, what this is saying, is that this the vendor must sell 350 t-shirts for $10 each to break even. Okay, the vendor must sell exactly 350 shirts at $10 each to break even. Now, could we have found that answer with the calculator? Let's go ahead back to our graph, and let's see if we can ask the calculator for that answer. We want to know what the equilibrium point is at that point. To do that, you press the second trace and select number 5 to calculate the intersect. Then press the enter button 3 times. And there it is. We have the answer from the calculator. So if you're smart and you know exactly what you're doing, then you wouldn't need to do this algebraically, okay? The answer confirmed with calculator. Okay, so confirm answer with calculator. Now, the next question is asking us to determine the price for which the quantity demanded is greater than the quantity supplied. Okay, so if we solve this inequality, we would have negative 135p is greater than negative 1350, Then if we divided both sides by negative 135, the inequality would flip and P would be less than 10. Okay. The prices for which the quantity demanded is greater than the quantity supplied is any number between 0 to 10. Between 0 to 10. That's what this is saying. So from 0, remember, the t-shirt cannot cost more than 0. It can cost $0. Okay. The price of the shirt is between 0 and $10, for which the quantity demanded is greater than the quantity supplied. Pay attention to that inequality flip when you divide, from because it changes from greater than to less than. Okay. Price can equal 0, but not less, because the price can't be negative. Okay. So, and that probably makes a little bit of sense, because in this, if you have a situation where people are asking more for more product than the amount sold, then it will affect the price. Then the quantity being supplied by somebody, then it will affect the price in a way where you have to lower the price. Now, here they give us a situation to think about. What will eventually happen to the price of the t-shirts if the quantity demanded is greater than the quantity supplied? So eventually, and if you think about what happens at concerts, that eventually the price is going to increase. Because it would cause a shortage if people are asking for more product. It will cause a shortage in the product, and so the vendor will start raising the prices. Okay. Although the price would be between $0 and $10 initially when the quantity is greater than the quantity supplied. Remember, this is the quantity greater over the red line is the quantity greater, and the blue line is this is the greater red line, the greater, and the blue line, the I'm sorry, the red line is the demanded, the blue line is the supplied, and the red line is over the blue line between 0 to 10. Okay. But as that continues, the market is going to have a shortage and the price will increase. Kind of a common sense question, yeah? All right, moving right along. The point at which a company's profits equal 0 is called the company's break-even point. We saw that just now, right? The equilibrium point. Let R represent the company's revenue. Let C represent the company's cost. Let X represent the number of units produced and sold each day. A, find the firm's break-even point, that is, find X so that R is equal to C. Okay, so remember, X represents the number of units produced. Let's set R equal to C and solve for X. So we've got, and you can see the similarity in to the previous problem, yes? 200X is equal to 110.5X plus 89,500. So taking away 110.5x from both sides, we get, let's see, that is 200 minus 110.5, 89.5. X is equal to 89,500. Then divide both sides by 89.5 and we get X is equal to 1,000. In the context of this problem, the company will have to produce 1,000 units to break even. Find the values of X so that Rx is greater than Cx. Okay, so they're asking us to solve the same problem as an inequality greater than 1110.5x plus 89,500. So 89.5x is greater than 89,500. So x is greater than 1,000. Okay, so for revenue to be greater than cost, to be greater than cost, company must produce more than 1,000 units. Okay, more than 1,000 units. All right, moving along. So before I do this part, I want to just speak a little bit about depreciation and what depreciation is. Okay. This is an explanation for problem 3. I'm going to put a line here and explain it. Straight line depreciation is the default method to recognize the carrying amount of a fixed asset over its useful life. Um, if you think about something like your car value, so you buy a car purchase for $35,000, and then you go to Kelly Blue Book after 10 years, would probably tell you your car is worth $0. Okay, they've used straight line depreciation to tell you that your car that you bought for $3,500 at year zero, after 10 years, is worth nothing. Now, keep in mind that that depreciated value may not necessarily be the real value of the car. If it's a good car, you probably could sell it for some money, but the book value after 10 years is $0. So we have a few parts to answer for this problem. Let's go ahead and try to answer all of the parts here. Okay. Suppose that the company has just purchased a new computer for $3,200. The company chooses to depreciate using the straight line method for 4 years. Write a linear function that represents book value V as a function of age, let's say in years, right? And book value would be in dollars, yeah, dollars. So essentially we're looking at y is equal to, let's say v is equal to mx plus b, right? Now, it's telling us that the computer is 3,200 over 4 years, so we have to find slope. Okay, at year zero, the computer is $3,200, and at year four, the computer is $0. So the slope is y2 minus y1 over x2 minus x1, which is negative 3,200 divided by 4, or negative 800. All this means is that the computer is losing $800 every year in value. So V is equal to negative 800 x plus the initial value of the computer, which is 3,200. And this is your linear function. The domain of this function, x, is from 0 years to 4 years. In other words, 0 to 4. Graph the linear function. Let's graph the linear function. So I need a little help here from one of these, maybe one of these things here. How about that one? Yeah. Can I graph it right here? See? So here is my V, and here is my X. X starts at 0, 1, 2, 3, 4. And the value goes up by $800, goes down by $800 every year. So 800, 1600, 2400, 3200. Yep. At year 0, the graph is worth 3200. At year 4, the graph is worth $0. Put a line through those points and you've got your graph. Okay? Put a line through those points, you have your graph. Part D, book value after 3 years when X is equal to 3, V is equal to negative 800 times 3 plus 3200, which is negative 2400 plus 3200, or $800. And you can probably get that from the graph, yeah? At year 3, the graph is $800. And part E, when will the computer have a book value of $2,400? So when would V find X when V is equal to 2,400? So 2,400 is equal to negative 800X plus 3,200. So negative 800X is equal to 8, negative 800. So X is equal to 1. Okay, what this is saying is that at year 1, book value is $2,400. And you could also get that from your graph, yeah? At year 1, the book value is $2,400. I just want to make sure you know how to graph something like this with your computer, with your calculator. So let's go in here. We can clear that graph that we've got in there. Clear the other graph. And then put in our function, which is negative 800x plus 3,200. Fix your window. X is equal to 0. Y is equal to 4. 4 years. That's the domain. And then the price goes from 0 to 3,200. In graphic. Okay. And you can use your graph to, say, find out year 1, year 2, year 3. Let's say we wanted to calculate what happens at year 2nd, calculate the value at, say, year 2 or year 3. We can see the value is $800 here. I'm going to put that little graph in here so you can have it and check on your answer. And this kind of shows the 800 for that problem, yeah? If you wanted the graph. All right, one final problem. think I lost the problem. I'm going to have to pause this for a second and see if I can find it. Yeah. Okay, I found it. All right. A truck rental company rents a moving truck for one day by charging $23 plus 6 cents per mile. Write a linear equation that uses C, the cost in dollars, and X, miles driven. Now they gave us some information, right? They gave us the B value, initial cost is equal to $23, and the slope, the rate, is 6 cents per mile. So C is equal to mx plus b. So C is equal to slope x plus 23. And then they ask us two questions. What is the cost of renting the truck if it is driven 125 miles? So when x is equal to, 126, cost is equal to 0.06 times 126 plus 23. Put that in your calculator. And we see the cost for 126 is $30.56. And when x is equal to 317 miles, the cost is 0.06 times 317 plus 23. Calculator, $42.02. Okay.